Okay, so here we go. We have another lecture for you today. This is college algebra, and this is section 1.7, and this is called linear inequalities. Okay, so linear inequalities, let's look here. We have A, okay, this is -1, 4, okay. So, what are these things? This is what? This is interval notation, right? So you have some number and you have some other number. And what are you going to do? Well, we're basically putting these numbers on a number line, and then we're shading them and we're saying, hey, look, this thing right here represents all of this. Okay, wonderful. Well, how else can you write it? Well, you can do it like this with inequalities, just like this. Okay. So we have -1 to 4. It's this entire region right here. And what this means here is what? Not included. And what does this mean right here? Included. Okay, so this means not included. This means included. So another way of thinking about this is open and this is closed. Okay, great. All right, let's look at another one. So what if we have this 2.5 comma 4? Okay, and these are both closed here. So we have a number line, okay, this is 2.5, okay, and this ends here at 4, and we have this, and this is an entire region, and it's closed. So 2.5 less than or equal to x less than or equal to 4. That's right. Okay, what about something like this? -4 to infinity. Well, what does infinity mean? Well, that means something like this. Infinity means, well, it's just going to keep on going. And it's going to keep on going forever. Okay, so this is finite. This is finite over here. But this is infinite. Okay, so this is x is bigger than -4. So these are some inequalities right here. Okay, so let's look at some more here. So what if I have this? Okay, what if I have this? So this is A, this is 1, 3, okay, and this is intersection, and this is 2, 6, okay, and the 6 is open. Okay, well, let's look here. So let's try to use some color here. This is a 1. So this is a 1. There's a 2. Okay. Then there's a what? There's a 3. Okay. And then there's a 6. Okay. Let's use a different color here, green. So the 1 and 3 covers this one and this one. And the 2 and 6 covers what? That covers this one and this one. Okay, well, intersection means what? It's going to be the overlap, right? So we have this interval, okay, right here, this interval, and then we have this interval, okay? And we're looking for the overlap here. So what is the overlap going to be? Well, and I kind of messed up here because this is actually open, but you can do it however you want. So this is going to be 2 and then 3. Okay, so 2 to 3, because this is actually open right here. Okay, so 1 to 3 is closed, 2 to 6 is open. And what are we going to get here? We're going to get 2 to 3. Okay, wonderful. All right, What about something like this? 1, 3 union with 2, 6. Okay. Well, the 1, 3 is going to be what? This is 1, 3, and this is 2, 6. And we are looking for the union of all of this. So you know what the union actually is? The union is what? You just put everything together. Okay, you put everything together here. And so you know what you're going to get? Well, you're going to get this. You're going to get 1 to 6. Okay, that's what you're going to get here. So intersection is usually called what? And. Union is or. And means you combine. Okay, it's intersection. Okay, intersection. Union means you union everything together, or collect all intervals. Okay. So let's do some problems here. So we have example number 3. Okay, we have 3 minus 2x, and this is less than or equal to 11. How do we solve this thing? Well, we do this, we do this. Okay. I think it's 8, 9, 10, 11. Okay. So then what are you going to do? Okay. Remember, if you divide by negative, what do you do to the inequality? You flip this thing, right? That's how you do that one. So what do we do? Subtract 3 from both sides, divide by -2, flip the inequality, and here we go. We have x is greater than or equal to -4. Okay, what about this one? -2x minus 4 is bigger than x plus 5. So how do we do this? Well, and there's many different ways of doing this. But let's see here. We have -4 greater than, we have 3x plus 5. We have a minus 5. We have a minus 5. We have -9 is greater than 3x. Divide by 3. And what are we going to get here? We are going to get -3 is bigger than x. Okay. And what's really cool about these is that you can actually write them. So x is bigger than or equal to -4. You can actually write them like this. So x is bigger than or equal to -4. -4 to infinity is the same thing as x is bigger than or equal to -4. Over here, x is less than -3. So you have to think this is -3, and we're going to go less than that. So we're going to go this way. So this is -infinity to -3. So pretty neat, right? So you can actually graph these things. So x is bigger than or equal to -4. Okay, bigger than or equal to -4. So something like this. So very cool stuff here. Okay. What about something like this? We have x plus 3, and this is divided by 4. And this is bigger than or equal to x minus 2, and this is divided by 3, and this is plus 1 over 4. Okay, so how do you do this? Well, you probably multiply the whole thing by 12. Okay, so this is 3x plus 9 greater than or equal to 3 goes into 12 4 times. This is 4x minus 8. And then 4 goes into 12 3 times. So this is going to be what? 3, right? So 4 goes into 12 3 times. 3 times this is this. Okay, so I'm just reducing these. So the LCD is 12, and it clears all fractions. Okay, so let's look here. 3x plus 9 bigger than or equal to 4x what are these two together here? I think this is -5, okay? -3x, -3x. So this is 9, bigger than or equal to what? X minus 5. So we have 9 bigger than or equal to x minus 5. If we add 5 to both sides, we will get what? 14 bigger than or equal to x. Okay. So I think that is, I think that's the correct answer. So x is less than or equal. So here's 14. Okay. X is less than or equal to 14. So in other words, negative infinity all the way up to 14, like this. It's the interval notation. Okay. How about this? How about this one? So example number 6a. We have 2 times x plus 4. We have greater than, we have 2x plus 3. Okay, so this is 2x plus 8, bigger than 2x plus 3. These guys are going to go away, all right? And then we're going to get 8 is bigger than 3. So here's the deal with 8 bigger than 3. It's always true, no matter what, for any x value. It's always true. Great. What about this? Here's another example. This is part B. What if I have this? X plus 7 less than or equal to x minus 2. Well, if you have an x over here and an x over here, those are going to go away. So you just get 7 is less than or equal to -2. Okay, so you have to ask yourself, is this true or is this false? So this right here is going to be false for any x. Doesn't matter, any x value I plug in here, this is always a false statement. So these are kind of like identities, but only with inequalities. Okay, so here's another example. Example number 7. You have -3 is less than 2x plus 1 less than or equal to 3. Okay. So what's going to happen here? Okay, well, I can do something like this. So here I have -4 less than, we have 2x less than or equals. This is going to be 2. Okay. We divide by 2 on everything. So we have -2 less than x, and then we have less than or equal to 1. And we can graph this thing because we can say, hey, here's -2, here's 1, and we're going to do something like this and something like this and shade in the middle. And guess what we're going to get? We're going to get this nice little interval right here. All right, what about this? We have x minus 4, okay, less than 3, okay? And we're trying to see what this is because this is absolute value. Well, you can do something like this with the absolute value. You can separate it like this, where you take this number, make it negative, take this number, make it positive. Okay. So this is going to be what? 1x less than 7. Okay. So what is this going to look like? Well, we have 1 and we have 7. Okay. And we're going to get this nice little interval 1, 7, just like that. Okay, so any questions on these inequalities? So basically these inequalities, we have these numbers and we have these regions. Actually, we have one more to do. We have these intervals, we have these regions, and we basically solve these things and find out the intervals. Okay, let's look here. Okay, we have example 10. Okay, so this is actually going to be what? This is going to be 5 minus 2x, and this is going to be bigger than 7. Now, this is kind of tricky because what you end up doing is this, 5 minus 2x bigger than 7, or 5 minus 2x is less than negative 7. So this is the sneaky part right here. This is the sneaky. This is the sneaky part. Okay, this is the sneaky part because this is what's different. This stays the same. This changes. Okay, does everybody see that? Does everybody see how this is identical to this, but this part is different? Okay, so subtract 5, both sides. We have negative 2x bigger than what? 2. We can divide by negative 2 over here. What are we going to get? X is bigger, but wait a minute, we flip. Okay, x is less than negative 1. And then over here, we have 5 minus 2x less than negative 7. So what we're going to do is we're going to subtract. We have negative 2x less than negative 12. Okay, we are going to divide, and then we are going to flip, and we get a plus 6 right here. So this is x is less than negative 1. This is x is bigger than plus 6. And you can graph these. So this one is kind of tricky. It's a tricky case because it doesn't work like the other case, okay? This case right here, this case you can separate it with a negative and a positive. This case, you're actually flipping the inequality, which makes it a little bit more different. So you have to really look out for this one, okay? This is a special case right here. Okay, so any other questions? Any other questions with any of this? Because that is going to conclude our lecture for linear inequalities.